the habitable zone, a hostile frontier for life. We call it the habitable zone, the promised land where another Earth might be waiting. But the brutal laws of astrophysics reveal a more formidable reality for nearly every world found there. This isn't the cradle of life, it's a dynamic environment of extreme stellar influence. The soft glow of the main screen cast long shadows across the control room, illuminating the focused faces of Dr. Eris Thorne and Dr. Lena Petrova, a knot of cold, professional dread and old and unwelcome companion on nights like this tightened in Lena's stomach as the final data packets from the TRAPPIST-1 system began to resolve. For weeks, they had been pointing their instruments at this faint red dwarf, chasing the ghost of a signal that promised not one, but a procession of rocky worlds. The initial results were better than they could have imagined, confirming planet after planet neatly arrayed within the star's habitable zone. Look at that, Lena, Eris breathed, his voice a low murmur that barely disturbed the quiet hum of the servers. The raw hope in his tone was a fragile thing. A flickering light she feared the unforgiving physics of the cosmos was about to extinguish. He gestured toward the orbital plot, a beautiful, concentric diagram that looked like a blueprint for a new solar system. E, F, G, all in the sweet spot. Liquid water could exist on any one of them. We could be looking at the first real candidates for an Earth 2.0. Lena's gaze, however, was fixed on a different data stream, the telemetry detailing rotational and orbital periods. Her own excitement had begun to curdle into a grim suspicion the moment the resonance lock became clear. The numbers were too clean, the orbits too perfectly synchronized, a clockwork precision that spoke not of life's chaotic dance, but of an immense gravitational tyranny. She initiated a simulation, her fingers flying across the console with practiced efficiency as she input the final variables. The result bloomed on her private monitor, a stark and brutal confirmation of her fear. They're all tidally locked, Eris. The words felt like a sharp, cold realization. The vibrant hope that had filled the room moments before seemed to bleed out, leaving a vacuum in its place. Eris turned from the main screen, the joyful light in his eyes dimming as he saw the simulation she was pushing to the central display. The program showed each planet as a starkly divided sphere, one hemisphere glowing a furious, permanent red, while the other was shaded a deep, frozen blue. They were not rotating, they were trapped, forced to present the same face to their parent star for all eternity. The prospects for a temperate, Earth-like environment were significantly diminished, replaced by the image of a body held perfectly still before a raging bonfire, its front forever burning, while its back remained locked in a perpetual, extreme thermal gradient. Eris moved with a stiff, deliberate motion, breaking the heavy silence that had fallen over the control room. A desperate, defiant spark still burned in his eyes, a refusal to accept that their 7 new worlds were already lost causes. "The star," he said, his voice flat but determined. "We've been so focused on the planets, we haven't properly characterized the M-dwarf itself. Let's pull the full photometric history." Lena watched him, her initial dread now solidifying into a cold, hard certainty that felt like a weight in her chest. She knew what he was looking for. A loophole, a mitigating factor, some small piece of data that would salvage their discovery from the scrap heap of failed candidates. It was a fool's errand, but one she understood completely. The silent command clattered through the network, redirecting the observatory's focus from the orbiting worlds to the small, dim star that held them captive. The data began to cascade down the screen, a river of numbers that Eris quickly translated into a light curve. The line was not stable. It was a jagged, angry thing, a seismograph, reading of a star in a constant state of fury. He ran a spectral analysis, isolating the high-energy bands. The screen lit up with plots showing violent, erratic spikes in X-ray and ultraviolet radiation. They weren't just flares, they were superflares. Eruptions of energy so powerful, they made the tantrums of our own sun look like minor sparks. "The frequency," Lena whispered. leaning closer as the system calculated the intervals. Some of these are happening just hours apart. A sober, grim acceptance settled over them, a final shroud on their extinguished hopes. The delicate balance required for a stable atmosphere was impossible here. Aris ran another simulation, this one modeling atmospheric retention. He input the planetary masses, their estimated gravities, and then overlaid the stellar radiation data. On the screen, the hypothetical atmospheres of the TRAPPIST-1 worlds were not just eroded, but relentlessly stripped away by stellar activity. High-energy photons would slam into the upper atmosphere, heating gases to a frantic boil until their thermal velocity exceeded the planet's gravitational pull. It was accelerated Gene's escape, a relentless storm of particles scouring the planets bare. They looked again at the pristine orbital diagram, a perfect model of stability and promise. Beside it now was the portrait of its parent star, a chaotic and violent engine of destruction. The juxtaposition was sickening. They had found what looked like the perfect online listing for a new home, a place with ideal dimensions and a promising location. But they had just arrived at the property to discover it was situated within an environment of intense, unrelenting stellar radiation. The very air poisoned by the source that was supposed to give it life. The promise of shelter was a complete fabrication. There was only one piece of the puzzle left to place. One final, damning variable to check. An almost unbearable weight settled in the room. The silence thick with unspoken conclusions, as Aris keyed in the commands for the magnetometer survey. Even if, by some miracle, an atmosphere had formed on these worlds, it would have been subjected to the full, unmitigated fury of that red dwarf. Without a defense, it would be a losing battle, fought over millennia and lost in an instant. The models indicated a lack of significant magnetospheric protection. The planets were inert, their iron cores either frozen solid or rotating too slowly from the tidal lock to generate the dynamo effect that could save them. The crushing weight of their findings wasn't a sudden impact, but a slow, suffocating pressure, the finality of a diagnosis with no hope of appeal. Every single promising world in the TRAPPIST-1 system was utterly, hopelessly defenseless. With a quiet resignation that felt older than the stars they studied, Aris pulled up a new window on the main screen. He didn't speak. He didn't need to. On the left, a familiar blue and white sphere appeared, a simulation of Earth. A moment later, its invisible armor flickered into view. The elegant, sweeping lines of a powerful magnetic field, the model's solar wind, a stream of glowing particles, flowed from an unseen sun and washed over the planet, parting around the magnetosphere like water around the bow of a ship. It was a shield of impossible strength and grace, a silent protector that made life possible. Then, he placed a model of TRAPPIST-1F beside it. He used their collected data, rendering a barren, irradiated rock, bathed in the harsh glare of an M-dwarf. He initiated the flare simulation, a torrent of high-energy particles, far more violent than the gentle stream hitting the virtual Earth, slammed directly into the planet's surface. There was no shield, no deflection. It was a direct and catastrophic bombardment, a vision of a world sterilized down to the last atom. Staring at the two images side by side, they finally had the answer. The habitable zone is a simplified model, a restrictive environment that promised shelter while masking the destructive forces of the parent star. Being an Earth-like rock was meaningless without the shield. This was the great filter, the unforgiving law of physics that ensured the cosmos was filled with silent, barren worlds. The search for an Earth 2.0, for a Plan B, was predicated on a fundamental misunderstanding of their own existence. They weren't looking for a commonplace haven. They were inhabitants of an impossibly rare oasis, an exceptional statistical anomaly that had won a billion-year-long lottery against sterilization. The cosmic shooting gallery claims another set of worlds, leaving behind a sobering galactic silence. That profound hope of finding a reflection of ourselves out there in the dark feels more distant than ever, a quiet ache in the heart of our collective search. The promised land we once imagined in the habitable zone was never a cradle for life, but a restrictive environment with a violent secret. It forces us to look back at our own fragile world, not as a starting point, but as the impossible prize from a lottery we never knew we were playing. Unraveling these hard truths to understand our place in the cosmos is the core mission here at Dissect Official. The data, however, always leads to a human question. If you truly accept that Earth is a statistical miracle with no viable plan B, does that fill you with a greater sense of duty to protect it, or a profound sense of cosmic loneliness? Thank you for joining us in the breakdown. Until next time, stay curious. But if the universe's most common stars are off the table, it forces us to ask a profound and unsettling new question. What happens when a perfect life-giving star, like our own sun, begins to die?